I can see there are several relevant ones to electrocution, falling object, fall from height. So these are a lot of the things you've put there, okay, are valid, okay, causes of accident. They not follow the rules. That is not following rules, okay, improper handling of tools in the bad weather. So we can see that a lot of the things that you have mentioned here are also things that were reported, okay, from the analysis that the team at Loughborough did, and also from the from the accident causation models that I've shown you. Okay, so let me quickly show you the responses from last year. Okay, so last year, so similar responses, but by students. Okay, fall from height. Okay, so fall is a big one, and I can see that a lot of you also mentioned fall from height. Okay, last year to fall from height was the most prominent I can see. Fall from height. Okay, that's a big one. And then, so a similar response profile. So last year, okay, so none of this. So the majority of students did not say it is permanent works design. Okay, so it's similar to what you are saying. Okay, yeah, but now we know that permanent works design, okay, is an underlying cause of accident. Okay, so let's move on. Okay, so my third question to you is this: which stage of a construction project life cycle offers the greatest ability to influence safety? So I'm going to move on to the next one. Okay, so please respond to this next quiz. Okay, so I'll give you maybe 2 minutes, okay, for you to do that. Then we can move on. Okay, so let's see where we are with the responses. Okay, so let's continue. Conscious of time. Okay, we can have time for questions. Yeah. Okay. Okay. Okay, so let me continue sharing, and then we'll see. Okay. Okay. Okay, so you can see that, so most of you are saying design. Let's see if that's correct. Okay, so let's move on. I'll come back to the quiz. Okay, so this slide answers that question. Okay, so we can see the various stages or phases of a construction project, and this axis, okay, talks about refers to ability to influence safety, and this one is a start, so that's the time. Okay, so this chart shows that we have the best chance to influence or improve safety at the early phases of project. Okay, so as we move towards construction and handover, okay, we lose that influence. So that influence, decreases. Okay, so it's just like in quantity surveying or cost management. Okay, we know that the ability to influence cost, we have the greatest chance to influence cost at the early stages via design. Okay, so we can design things to be more cost effective. Okay, but if we miss the chance during construction, it's more expensive. Okay, to do that, because if you make a design change, okay, during construction, that can be very expensive. Okay, for example, during construction, you designed the building to be 11 floors, and then during construction, you now want to make the building 20 floors. That's going to be very expensive because you may have to go back and redo the foundations, okay, so that you can add more floors to it, and that will require underpinning and other things, which will be very, very expensive, which will be very expensive to do. Okay, so this chart answers this quiz. Okay, it gives the answer to this quiz. So those of you who chose design, yeah, you're right. So the design stage offers the greatest ability to influence safety. So that's right. So let's see what students said last year. So last year the responses are largely similar. So the majority of students also said that the design stage offers the best chance to influence safety. Okay, so hopefully you are aware of what's happening in Malaysia now, with previously with OSHIM, but now with CDM. Hopefully that has raised awareness, okay, about the importance of the pre-construction stage, particularly design, okay, to improving safety and health within the construction industry. Okay, so moving on. Okay, so this raises the importance of the design phase. Okay, and it shows that planning and design, okay, are most important stages, okay, to positively and effectively influence safety. Okay, so that's where construction professionals make critical decisions. Okay, so this brings to the fore the concept of design for safety, or design for occupational safety and health, or prevention through design, or safety in design. Okay, and the concept says, the whole idea is that there's a need to anticipate and design out occupational health and safety hazards associated with a structure or a building during design. Okay, so that's the whole concept. Okay, well, that's what the design for safety is about. Okay, so what can we do during design, okay, to remove any anticipated hazards, okay, or to reduce those, to reduce risk associated with those hazards. Okay, and design for safety aligns with the hierarchy of risk control. Okay, and the hierarchy says that, okay, when dealing with risk, first and foremost, we should try to avoid the risk by eliminating or substitution of hazard. If that is not possible, then we move to reducing, okay, isolating, using engineering controls, using safe systems of work, provision of training, and as a last resort, we need to provide personal protective equipment. So PPE should not be the first action. Okay, although it's very important, we need PPE on construction sites. Okay, yeah, but that should be the last resort. Okay, the first thing we need to think about is how best can we remove the hazard or reduce it. Okay, and when we are looking at design for safety, we are thinking about using design, okay, to be able to do that. So to eliminate the hazard or reduce it via design or design decisions. Okay, yeah. Okay, so I think this is a repeat, which of the following can be described as an unlearned course. So I think, yeah, we know that already is that. So I'm not gonna bore you with that. Okay, no, I think I move on to the wrong slide. Okay. Okay, yeah. Okay, good. Okay, so moving on, I'm going to talk about, some research that I've done. Okay, some of them with the team at Malaysia. Okay, at UITM. Okay, so over the years, through my supervision of dissertations, I have undertaken several studies about design for safety. Okay, trying to understand awareness, knowledge, practices, and factors that influence it. Okay, from various countries. So I've supervised dissertation from students from Palestine, that's particularly the West Bank, Botswana, Kuwait, Malaysia, Ghana, Nigeria, and northern China. Okay, but I then recently I saw that someone has done a similar study to the ones that I've done. Okay, with students in Vietnam. Okay, so I would just want to tell you about some of the insights, okay, from these studies. Okay, so these studies are focused on trying to assess or examine the awareness, knowledge, practices, okay, and influence factors of design for safety from the perspective of designers. Okay, so the people or the practitioners who have been involved in those studies are architects, civil structural engineers. Okay, so people who are involved in design, okay, within the construction industry. And in terms of experience, okay, some of them is dependent on the country. So some of the surveys, we did surveys, some of the surveys have been responded to by people with over 5 years of experience. So, and in some places they were in the majority. For example, in Botswana, over 70%, in Kuwait, over 60%. Okay, so a good representation of experienced people, okay, involved in those surveys. And we also wanted to understand their professional membership or affiliation. So in several of the countries, the people who responded to the surveys are professionals within the industry. Okay, so for example, in Palestine, over 90% of them. In Ghana, just under half of the people. Okay, but in Nigeria, over half of them. In northern China, less than 20. So fewer of them were members of a professional body. Okay, yeah. So this just gives you an idea of the characteristics of the people who responded. Okay, and we wanted to understand the awareness, if they've undertaken any lessons, training, their interest in doing training, and what sorts of modes of training they'll prefer. So generally, what we realized is that in all the countries, over half of them, and in some places over 70% of them are aware. Okay, so we can say that largely awareness of design for safety concept or practice is high, okay, across all the countries that we surveyed, including this one, which we didn't do. And then we also realize that there's a high interest in doing design for safety training, DFS training, okay, but this doesn't correspond to the percentage who have engaged in training. So although there's a high interest in training, but actual engagement in training is very low. So all over, less than half of them okay, had actually done any design for safety training, okay, which is very interesting. So which shows that interest in training doesn't necessarily result in people doing the training, and there could be several reasons for that. Either maybe their work environment isn't supportive of they doing training, or maybe they don't have the resources to go on to those training, or there aren't any training or training providers or sufficient training providers available for people to go onto them. Okay, so that tells us that something needs to be done in this area. But we also wanted to know what mode of training they want, whether they want in-person seminar or online. Okay, but most of these were prior to the COVID, and so we see that in some places there isn't much difference. Okay, so for example, in Kuwait over here, but in some places we see that there are differences. Okay, we see that there is a maybe higher preference, okay, for in person, and in some places there's a higher preference. Okay, there may be a higher preference for online. Okay, I think this one we did it just around the COVID time, okay, or either before or maybe around the COVID time. So that may explain why we had about 80% of them saying they like online, but these are the ones who were prior to COVID, okay, and so we see that then, uh, you know, online stuff weren't as very common, and people were probably more used to doing things in person, okay, and so that may explain why that, for example, here and there people prefer the in-person. But the whole point was that there's a need to gauge, okay, what people's preferences are so that we can design training, okay, to reflect their preferences. And then we also investigated design for safety practices, okay, several practices, about 15 practices, and those 15 practices are related to prominent causes of accidents like fall from height, okay, working in confined space, okay, and so on and so forth, okay. So we wanted to know whether these designers, when designing, they make an effort, okay, to address, okay, risks, okay, associated with these uh, uh, items. Okay, so we have here, for example, I design to minimize or eliminate the need for workers to work in confined space. I design to eliminate materials that could create significant fire risks during construction. I specify materials that have less hazardous chemical constituents. I specify materials that are easier to handle, such as lightweight blocks. Okay, so trying to see what designers do, okay, to be able to prevent, eliminate, or to reduce risk, related to some of these prominent causes of accident, okay. And we use a scale of 1 to 5. So 1 is never, 5 with always, that is they always do it, okay. And when we analyzed the data, we realized that in some countries, okay, so in some countries and for some practices, the level of engagement in those practices are very low. Okay, so for most of the practices, for example, the ones I've circled, I've put a red triangle around. So level of engagement, okay, across board, okay, is not encouraging. So it's only a few practices. So this one and that one, that you can see that in most of the countries, over 50 or over, I think over a majority of the respondents say that, okay, they do those practices often or always, okay. So this and that, okay, but across board, it's not looking positive, okay. But again, when you look at the country specific responses, generally we saw that in most countries, level of engagement in these practices range from low to moderate. Okay, it's only in Malaysia that we saw that people are generally, the response suggests that, okay, there's a high level of engagement in design for safety practices. So 11 out of the 15 practices we investigated, okay, largely people said that they either often or always engage in those practices. Okay, but for the other countries, we see a low level of engagement, or you can say a moderate level of engagement. Okay, so the high level of engagement may be a reflection of OSHIM. Okay, because when we did the survey, OSHIM had been introduced. Okay, OSHIM had already been introduced, and so perhaps that may explain why we had these responses from there. Okay, so let me move on quickly. And then we also investigated the factors that influence design for safety. So several factors. Okay, so 2 factors across all countries. The respondents said that they are influential. So legislation, okay, or emphasis by government is very important if you want to drive design for safety. And it's not surprising that in Malaysia and Singapore, they have introduced, laws or legislation, okay, to promote design for safety. So hopefully with time, it's going to become embedded within, design practice or construction practice in Malaysia. Okay. And in some countries like Malaysia and Palestine, the respondents said that all of these factors, so education, ICT tools, client influence, training, all of them are influential. So that gives us the impression that there's a need to understand the situation in each country, okay, in order to be able to design relevant or appropriate measures or interventions to be able to promote, design for safety implementation. You cannot simply assume that, okay, because this country, this situation, that will automatically apply, to another country. Okay, we cannot assume that. Okay, so moving on. And I also did, as part of my studies, I looked at several journal articles to see how these factors have been examined or researched, okay, in the literature. And we realized that, okay, a lot of the studies in literature focus on, designers' awareness, knowledge, and education, but some of the other factors, okay, less research has been done. So that creates an opportunity for researchers and students like you to look into, some of these under or less researched, factors that influence design for safety. Okay, so now let me move on to talk about some case studies. Okay, so design for safety in practice. Okay, so I'm not going to go into detail because I'm going to send these slides to you later on. Okay, but these are case studies that show the application of design for safety. Okay, I'll just pick one of them. Okay, and then I'll display that here. Okay, yeah. So this case study, it's providing roof anchors. Okay, so that when people work at height, or maybe they go up in the roof later on to do some maintenance work or some refurbishment work over there, okay, they can get hooks, okay, to hook their maybe fall protection equipment to. Okay, so this is just place installing roofing residential roof anchors provides a place for workers, okay, to tie off. Okay, so this is just an example of what designers could do, okay, in terms of design for safety. Okay, so let me move on. Okay, so still on practice. So several countries have introduced legislation in Australia, UK, Singapore, and more recently in Malaysia, okay, to promote design for safety within the construction industry. And looking at UK's as an example, so these regulations have specific duty holders, and these duty holders have specific responsibilities, okay, under the regulations. The whole idea is that health and safety is not just a responsibility of one stakeholder, okay, but several stakeholders, and these stakeholders have responsibilities under the CDM regulations, okay. And if hopefully those responsibilities are kept, we will have safer construction projects, okay. And still about, talking about our practice. So several tools have been developed, okay, to help with the implementation of design for safety. So I did a research that I did. I developed a web-based tool to assess the competence or the capability of design organizations or organizations with design responsibility. So to assess their capability to implement design for safety. And those case studies that I shared with you, you can find a lot more case studies on this website. I would strongly encourage you all to visit this website. There are several case studies about design for safety you can find over there, okay? So it covers various disciplines, okay? So I think I press here, okay? So if you want to see case studies about electrical, civil, structural, mechanical, architecture, so these are case studies that people have submitted, okay? Are showing how design for safety has been implemented, to address or deal with a challenge, okay? So I strongly encourage you to have a look at that, okay? And then another tool that I was part of its development is a BIM risk library, okay? I'll show you a very quick video about that. I think it's this one. Oh, so the video, I think it's from 11. So a quick shot.
We are going to look at ERIC formula. Of course, the earlier you identify the risk, the better. And most importantly, the use of safety base and perhaps treatment suggestion tool will allow you to take the approach from reactive to a proactive, where you can actually resolve risks and hazards before they happen on site. So in this case, let's say we just hide our issue pins and we focus on structural model. So I have a structural model, I have access to it, and right now I'm working remotely, and it's important for me to still be able to communicate with the team. We can't all be together in the same room. I can still have an effective tool that allows me to talk to them real time live. I navigate around my model, and should there be any hazard or risk, I can easily pick up on it and perhaps share it with the team. And in this particular case, actually, I've identified a risk, and as you can see, we have entrance to a car park. When they're going to be pouring concrete and actually erecting the superstructure, I might be worried about the fact that somebody may be walking across this and perhaps could fall down onto this drive. Maybe I want to share it with the team and make sure that something is done about this and nobody gets hurt. Should I want to take more information from the model, I can do that. I can check how wide this drive, how tall the actual height in here. It's over 2 meters, so it is pretty tall. If somebody falls, they may break a leg or something like that. As I identified, I can easily utilize safety base right here, right now. I can write the information about the risk itself, potential of falling requires a safety barrier or something like that. If I want to add more information to it, I can create a markup that will help me to articulate my point. So in this case, I might say, actually, I want to have a safety barrier in here, and I want to make sure that nobody falls down onto the drive leading to the car park. So I do a little markup, simple thing. I can place my pin if I want to, so that somebody who opens this model next time, they can easily see where the hazard is. The likelihood perhaps is moderate, but the consequence, in my opinion, is going to be rather high. So as you can see, it changes the color. And this is where it becomes really simple to utilize the treatment suggestion tool. We have all the fields of information defined. So in here, I can just quickly assign it to maybe a main contractor or somebody like that. But here I can actually pick any information about the input field from predefined fields of information. These could be defined by my company or by previous treatments taken on previous projects. As you can see in here, I might say it's a fall from open edge. What's my activity? Might be installation construction. This is perhaps to do with a slab, so it's a concrete slab here. And my risk factor is physical edge. Construction scope would be in situ concrete, and the location would be high level near edge. So there you go. I've easily identified and informed the team about the risk that exists in this design. But then what's really great is that I can actually make use of treatment suggestion. So when I open up my suggestion panel, here I have access to all that database, that single source of truth. I can then go and say, maybe this is a preliminary stage, maybe it's a detailed design stage, and then I can go and say, do I want to eliminate it completely, or do I want to reduce this problem? Maybe if I reduce it, the prompt suggesting me I should provide adequate railing and other means of fall protection. Maybe I...
Okay. Yeah, so you can have a look at this in more detail later on. Okay. Yeah, so it just shows how you can use, BIM, to help, with design for safety. Okay, so let me quickly move on. I'm almost done, so we can take some questions. Okay, and there are some industry groups, okay, that are, trying to promote design for safety and health, within the industry. In the UK, these are some of the groups, okay, that are available. Okay, and I think that brings me to the end of my presentation. Okay, and my last quiz for you is this one. Okay, so whilst I take questions, if you have any question, please ask, but also go and then complete the last quiz. Okay, so this is the last. Oh, come on. So this is the last quiz. Okay. Okay, yeah. So who is responsible for safety and health of workers on construction site? Okay, so I'm gonna stop sharing, and then I will take any questions. Okay. So any questions?
Okay, class, any questions? Thank you, Patrick. Yeah, question, please. I always make a rule with my student that they need to ask a question. If not, I cannot end the class, So they will delay the class if they don't ask the questions. Yeah, please. Where is the chat box? Is there any questions there? No?
No, I don't think there are any questions.
Because you have a lot of questions for them. That's why.
Yeah.
You have.
Oh, okay. Yes.
No, joking.
Okay.
All right.
Okay. If no question is, so then let's look at the last quiz. Okay. And then we'll just round up. Okay. So okay. So yeah. So most of you have said it's all of the above. Because safety and health is not the responsibility of one stakeholder or project actor. All project, team members, okay, stakeholders have a responsibility, be they client, designer, contractor, worker. So it's everybody's responsibility. Okay, so that's correct. And let me see what your colleagues said last year. So last year too, the majority of students said yes, it's all of the above. Okay, so that brings me to the end of the lecture. Hopefully it's been helpful. Okay, and you will hopefully be more engaged in DFS, okay, in Malaysia. I know that the team at UITM, they are having